All right. Well, hello there. Today's twin day, and Stan and I are twinning the way nature intended. Today we did a lab, and it turns out there's an online version for you, which I'm excited for you about. We are skipping all the bell work today. Hashtag lab life. Today we're going to think about why cells are shaped and sized the way they are. Cells need to be very specific shapes and sizes, as you'll find out, to maintain homeostasis. So today, indeed, we're finally going to look at cell size, which is the notes you took in 2.2. Reminder, the September field experience is now open, and in the back channel, you should be working on your Unit 2 study folder and, whoa, why? And AP Classroom, binder, paper, Unit 2 MCQ, progress check. Great, cool. And then tomorrow, we're going to start the water potential lab, and we're going to finish this one. So the water potential lab needs an overnight, and we'll be doing that tomorrow. Field trip Canvas form is due Friday. It's going to be great. Hopefully by the time you come to class, and if not sometime today, I'll update who's been able to submit their emergency medical authorization, just so you all know. The expectation is to come with us. It's really going to be great. It is a breath of fresh air, quite literally. You're going to meet some new people, do some new things, and be outside in a peaceful environment while you learn a little bit about setting the stage for Units 3 and Unit 8, which is Project 2 for us. All right, this is the small intestine, and you can see that there's stem cells down there at the bottom. Each of these dots is a nucleus. See the shape in your intestine? Those cells are working together to make a shape like this. And we even see that shape on the cellular level, whether we're looking at root hairs, for example, as you can see here. In this case, the cell nuclei are in magenta and the plasma membrane is in green. We see this shape, this protrusion, valleys, and we see it again and again and again in tissues whose job is absorption. So with that in mind, we are going to investigate the effects of cell size on a really important component of cells. So you can make agar cells, which I did last night. They are pink because they have phenolphthalein in them. Do you remember titrations in chemistry? It's that chemical. So I've made them basic. And if you put them into a cup of vinegar over time, you can start to see them turning clear as the vinegar changes the color of the phenolphthalein. So I want to make sure that we've talked through, this is a small investigation, so I want to make sure we've talked about the independent variable, the dependent variable, and the control variables here. So what are the independent variable for this experiment of investigating cell size? There are a couple choices. I'm going to tell you which one we're going to use in a moment, the dependent variable and the control variables. All right, so in this case, the independent variable you might have chosen time, how long it takes for the inside to turn pink. That's interesting, but not as interesting as graphing data. So that's what we're going to do together today. We are going to think about measuring in millimeters how much of each side has turned clear. And there's a protocol in front of you for that. The dependent variable is that percentage. That's what we're measuring. The independent variable is the size of the cells. So these cells were not quite made in the same shape, but it's really important, whatever you do today, that your cells are made in the same shape. And I think that's what you're going to see if you were learning remotely. Make a new page for this investigation. Do the pre-lab. If you have questions, let me know. This is supposed to be your salmon-colored piece of paper, and you can see this is the equation sheet for surface area and volume. So you'll see these equations. You do not need to memorize them. They will always be given to you. So if you were absent, somebody made a phenolphthalein experiment, and you can see they tried to make cubes where the only difference was the size. And you are going to pick 3 of them. In this particular case, you should use time as the piece of data you are collecting. So that's what's happening here. There's a stopwatch here. And then as you'll see, as you go through the video, it looks for, and you can watch and see when that pink is all gone in the middle. Pick any 3 cubes to work on. Maybe honestly, the 3 that, surprise, are going to go first. So we're skipping all the bell work. People who are here have to wash their hands. Tomorrow we begin our water potential investigation. I'll teach you a little bit more about water potential. We will talk more about this lab and collecting data about the millimeters. And we will get ready for the sort of calculations of calculating water potential in living cells. All right, that's it for me. Take care out there. Talk soon.